Thank you, Todd. Good morning, everybody. Can you guys hear me in the back? I think I can be a little loud, but as long as you can hear me, it's fine. It's always exciting to come down here and talk to you about managing Rhizoctonia. I think this is since 2015, so it's few years under the belt here. But I think talking this morning, I think there are some concerns about Rhizoctonia, right? When you think about Rhizoctonia, it's a full season pathogen. So, and I say that the time we put the seed in the ground until we harvest the beets, that's our season one. Season two, you guys take over, and then you have to process all these beets until May to get all the sugar. So that's the second season. What is that's killing our beets? Right? Is it Fusarium, or is it Rhizoctonia, or Actinomyces? I think last year was a good example. So I was surprised to see that May 25th planting dates, and as late as June 6th, it's some Actinomyces. Warmer soil temperatures, and with all the moisture, those are the few samples we saw early on in our lab. But one grower close to Brookston, he thought he was dealing with Rhizoctonia, so next time variety, and then he was he found something else in this field too. So guess what? It was not Rhizoctonia, it was Fusarium. You see these nice healthy looking beets here. Everything else was dead because right now the only solution for Fusarium is selecting a tolerant variety, right? So we have to really know 100% what that's killing our beets in the field. Number two, soil-borne diseases, pretty notorious. Rhizoctonia can survive in 2 to 3 years, whereas Actinomyces 10 to 12 years. So you plant beets in 2022, you don't grow beets until 2032, and I can guarantee you that if Actinomyces is there, it will just come back and it will kill the beets if you have a susceptible variety. So it's even more important for Actinomyces. So this particular field got both Rhizoc and AF, and look at the date there, right? So it's 2015, July 21st. 2 weeks after I took the pictures, there's barely anything left. I mean, I keep showing this picture every year. It's just the impact, what this can do as a mixture. And 2022, so in the last year I showed you only the data for the number of roots we got in our lab, but we are starting to get more and more leaf samples. That's because we're seeing a little bit more surprise other than Cercospora. So sure enough, it was late planting. We saw more of Actinomyces, and then few Rhizoc, and then about 8 Fusarium, and then some of these could be some chemical injury. And in terms of the leaves, actually there are more than 2 Cercospora in the fields, but I think most of those ag staff, they're pretty sure that's Cercospora. But some of the other ones, right, Alternaria, I know we saw more Alternaria, but in very low frequency in several things last year. And in addition to Alternaria, we saw also Stemphillium. That's kind of the cousin of Alternaria. I think if you remember, like 3-4 years ago, some of our friends from Netherlands, they talked about how devastating the Stemphillium in European countries. We're not there yet, but I think it is just very low frequency. And there is some bacterial leaf spot we saw mostly from southern Maine. You get those late planted beets and heavy strong winds, you get some tandering. When the soil is blown onto these tandered leaves, the bacteria can get into the leaves, but they're not going to impact any of the yield as you go later into the season. But some examples. This is very typical Alternaria, right? So you see extensive necrosis on the leaves. You don't see any circular spots like Cercospora here. But then even in some parts of the leaves where if the damage done well, laser was being colonized by Alternaria. But again, maybe the late planting, all the excess moisture that we had, at least in the Red River Valley area, Alternaria is a very good secondary pathogen, right? It just needs some dead and dying leaf tissue, so it can just go and colonize. So looking at the rainfall, I think, the winners are clearly for Renville and Montevideo, it's May, we got a good bit of rain and then no more in July. But, up in the valley, we got a lot of rain in April and May, and then it's kind of on the drier side for this, right? So some of the early moisture that was driving Actinomyces and a little bit of Rhizoc. But again, in the Red River Valley area, actually the early part of June was a little bit cooler. So again, Rhizoc was a little bit warmer, not that cooler. But as we went into the season, it got drier, so we did not see a ton of rhizoc developing later in the season. And look at this September, it's extremely dry, and some parts in July and August are also very dry here. So when we talk about rhizoc, I mentioned earlier, right? So it can kill the seeds in the ground itself. They don't even emerge. Or if they emerge, if the soil line, you can see the necrosis just here, and then pretty soon you will lose the seedling. Not only the seedlings, I think as the plants emerge later, now that some of the younger plants are more susceptible to rhizoc compared to the ones that came up right away and then start growing very quickly. So you can see some of those later emerged plants. Look at how healthy is this compared to the other one that's trying. And these are some of my research plots, but it's not uncommon for me to see some in the growers' fields as well. That's very severe. You lose all these crowns, pretty soon it goes down underground onto the roots. And at the end of the season, typically you see, a few plants dying in a row. Actually, this is very classic for rhizostonia. If you get a you're going to see that, several plants dying in a row, but you see a large patch of field that's actually affected by Aphanomyces. Whereas with rhizoc, if we follow corn and soybeans, you see like small to medium patches of dying beets. Because these spiders, right, only have these dried up videos. And then sometimes the beets look okay, but if you go around afternoon, you see a little bit of wilting. But if you see any dead plants right next to it, there's most probably there is some root rot under this. I mean, it's just getting started. But that's the only time you could see that root rot there. If you go in the morning, they just look perfectly fine because there's enough moisture. So end of the season, right? So we used to see more and more roots like this because of the crown rot, anyway, from the top of the root to all the way to the bottom. But we are seeing more and more, the crowns look more healthy, and you're seeing this root rot. Some of the work that we did in the southern Minnesota and also up in the valley there, it really depends. Some fields, I'm calling these as fields with a lot of soybeans and corn in rotation, just like most of your fields. And then there's a lot of Rhizoctonia in it. You could expect to see rhizoc all the way up to 6 inches. In some fields, it's only in the top 4 inches. In some, it's in the top 2. So it's highly variable. But where it gets on the root, the position in the soil is going to drive the infection, then it can quickly spread. What happens, right, when these beets die? Rhizoctonia makes these resting structures. We call this sclerotia. That's a 2-3B, and this 2-4 can survive for 2 to 3 years in the absence of host. But if you have soybean or corn in the rotation, it can happily perpetually grow there. Again, key points. There are still different anastomosis groups for Rhizoctonia, but we are primarily concerned about AG2. The other groups are not going to do much damage. Only these two are really important. Any crop that you grow other than small grains in the rotation, navy beans or soybeans, edible beans, corn, these are all good hosts for Rhizoctonia, right? So we talked about inoculum depth. Anytime you try to keep the soil away from the crowns, you want to help those beets, not have rhizoc getting into the crowns because there's more susceptible areas ultimately go on to the roots. So again, some of the research trials. We were looking at the breeding germplasm of soybeans for resistance to rhizoc. You can see the seeds rotting in the ground, and some of the younger plants, very similar to the sugar beets. You just lose this actively growing root area. Navy beans, very classic. We inoculate with the same rhizoc that we use for sugar beets on the navy beans here. You can see this row of plants dying. There's some healthy plant. It's kind of the escape here, but very classic pattern. So in 2022, we got a small research trial that's funded by the driving growers. So I'm working with Dr. Jeff Strock and then Dr. Nancy Bees. We're actually looking at the impact of grain spacing on Rhizoctonia, but in this particular case, this is with the navy beans. So I'm not going to show the data about the grain spacing, but what's more interesting is the impact of different treatments on Rhizoctonia in the navy beans here, right? So this is my untreated control. All we have is the base seed treatment, the allegiance, that takes of the other common pathogens here, right? So looks pretty happy here. It's actually 15-foot grain space. And the next one, we chose one of the seed treatments that are labeled for navy beans. In this case, it's Vibrance. Now this is like random choice. You can see little bit of yellowing, we lost some strands early on, but I mean, this is looking better, at least in this picture, compared to the untreated control. So here I have quadricide 9.5 fluid ounce grade, exactly the same thing that we do for sugar beets, 3 gallons per row, and then 3 gallons, and the rest of the 9.5 fluid ounce in 3 gallons. So we put 6 gallons in the furrow at the time of planting. I think most of the in-furrow treatments were looking pretty good, right? So at least from the picture here. So what about the data? You got the untreated control, seed treatment with the vibrance, and then the quadris here. So basically, the seed treatment was, more or less similar to the untreated control, slightly lower even. But the in-furrows had slightly higher plant population, 115,000 plants per acre. But the biggest difference we saw actually for the yield, both untreated and the seed treatments at about 38 bushels, whereas the in-furrow quadris about 48. I would say that's pretty significant impact. But again, the season we started with very good moisture. I think that was very conducive for Rhizoc to establish early on, and we could see the impact towards the season. So another good resource for what can you do in the rotation crops, you can consult this good publication from my colleagues at NASU. For all the rotation crops, you can follow some of the approaches for managing Rhizoctonia. So we talked about the things, but resistant varieties. I think now we're seeing about 50, maybe 55% will be CR plus, right? But anytime you're choosing a variety, please pay attention to Rhizoctonia too, because we have all the crops in the rotation. Most of the varieties are having some sort of susceptibility to Rhizoctonia. So it's very important to pay attention to those. And seed treatments, since 2014, a lot of options and the in-furrow fungicides. And then we have a few fungicides that work very well for as a post-emergence. So I'm going to show some of the trials that we did in 2022 here. So most of the seed treatments, they belong to one class of fungicide. It's called SDHI, succinate dehydrogenase. It inhibits a single enzyme involved in the respiration. So that offers pretty good protection for Rhizoctonia here, right? So some of the treatments that are labeled, and we included in 2022, Cabina, Vibrance, Cistiva, Zelterra, this is brand new since 2022. Again, metloxsweet in combinations with any one of these here, right? We primarily had metloxsweet and Zelterra this year, not the other combinations, right? Again, looking at the weather in Crookston, so we had a lot of rain in April and May. Red River Valley, were in town, so I guess it's pretty scary. I got only 1 foot left before the water could enter my backyard. But finally, thankfully, the National Guard was there to help the sandbagging. I was there as well. Look at that, 370%, 190% for April and May. Once we reach June, it's slightly lower than normal rainfall. July and August, it's pretty dry as we went later into the season, right? So some of the early moisture that delayed our planting, so we didn't plant until last week of May. Looking at the stand count, this is my untreated control, just the base treatment, nothing really selected for Rhizoctonia here for the seed treatment here. We started 2, 3, and 4, and 5 weeks after planting, roughly. And if you look at the days after planting, this is the number of plants per 100 foot of row. We started really low, 149 by 3 weeks, 188, and then slowly we lost some plants over time up to 5 weeks after planting. This is untreated control. Then looking at the seed treatments that we used, basically most seed treatments were actually slightly lower compared to our untreated control. This is something different that I saw this year compared to the previous years. But 2022 was the only year we started with absolutely like more than enough moisture, more than what we needed. But as we went later into the season, most of the seed treatments were actually slightly better than the non-treated control. Cabina, somehow it was slightly lower, but by 5 weeks, it caught up with everything in 2022. I mean, still pretty decent yields, right? At least 180 beats per 100 foot of row. In case of in-furrow fungicides, we basically mix 3 gallons of fungicide in 3 gallons water, 3 gallons 1030 per row. They go down the drip tube. We don't do any T-band like they do in Michigan. Every time they did the experiment in Crookston, it was always better than the T-band. So other thing to make note, 1030 for row. Some play very nice. They don't play that good. So as long as they have a good agitation in your tank, I think none of these cause any problems because when we test this every year, we have good agitation in our tank and we don't see any issues. 2022, we tested Quadris, Asteroid, Astronaut. The latest, it's a combination of again azoxystrobin and SDHI. Headline, Preaxter, it's a combination of headline and SDHI, and proline and propols. Believe it or not, these two you can still use as info, but we don't recommend that compared to Quadris and Asteroid. Fungicides, right? So I'm just going to show you some data for Quadris, Elatus, Asteroid, and Astronaut here. But talking to Weil, I think they want to promote Astronaut more for a post-emergence than the in-furrow fungicide. So look at this. The Asteroid was slightly better right out of the batch in terms of the emergence, but then both Quadris, Elatus, and Asteroid were all better than the non-treated control. And when we looked at the seed treatments, they're almost in line with this blue line that's non-treated control. Astronaut is more or less similar to the non-treated control here. Look at the other fungicides. Really, the only one that's really hurting stands was propols. Started off very low stands, but by 5 weeks it caught up with the other non-treated control and other in-furrow fungicides. But the top here are both basically headline and Preaxter. Excellent control for Rhizoctonia here, right? So this is at 5 weeks after planting. And when you compare seed treatments and in-furrows as a group, you can see there are certain days, especially at 2 weeks, 3, 4, 5, 6, and 7, there's a significant difference between seed treatments and in-furrows. In-furrows had slightly higher stands compared to the seed treatments or non-treated control, right? Like I said, by June, it was getting a little bit dry, so there's not a ton of disease pressure. But in-furrows, they started with really good stands and maintained the trend here. And at the end of the season, we actually rate these roots on a 0 to 100% root rot simulation, 1 to 10 scale, whereas 1 means 1 to 10% of the root is covered with Rhizoctonia root rot, 10 is 91 to 100%, right? So it's almost dead plant here. Again, looking at the data for the seed treatments and in-furrow, right? So we got about 184 versus 176 earlier, but now we have 153 beats versus in-furrow 164. Sometimes it's really difficult when you have more or less only 10 beats difference. You can still get a good ESA or RSA from the two different plots here. Look at the seed treatments, about 8,700. Look at the non-treated control, even better. But statistically, these are not significantly different, so they don't mean anything in terms of the numerical difference. The only difference we saw was higher stands in for treatments, and also it's 11% versus 7%, and it's such a slight difference, but still statistically significantly different. So what it's showing is the in-furrows are doing a better job over time compared to the seed treatments. And the other trial I wanted to show you was the post-emergence treatments. Again, we compared several different fungicides that are currently labeled for managing Rhizoctonia. This trial was also planted on the same date, that's May 25th. If you're wondering what's the same variety we used in the planting where I showed the seed treatments and in-furrow fungicides at 4.7 rating. So what we did, we came back on July 5th. We applied some fungicides, both at the 7-inch band and broadcast, and we inoculated with Rhizoctonia. We directly put this in onto the crown, so it's not going anywhere, and the infection developed, right? Every year we ask, in the grower surveys, are you doing broadcast or band for Rhizoctonia? 50% response. You're doing 50% band, 50% broadcast. Over the years, I was only testing broadcast, and I said it's about time for me to test every fungicide that works for Rhizoctonia, both band and broadcast. That's what we did in 2022. But we used only Quadris at lower rate and 14.5 fluid ounce. Asteroid at 9.2. This is equivalent rate of 14.5 for Quadris. It is a 7.1. And Excalia 0.64 fluid ounce. This is the only fungicide that's labeled for Rhizoctonia. If you use as a band, let's say if it's 7-inch band, you have to use 1/3 of rate. But if you use broadcast, fluid ounce. Whereas for all these other fungicides, the rate does not change whether you band or broadcast. That's what we tested. So that's my non-treated control. Inoculated with Rhizoctonia, we got about 33% of the root covered with Rhizoc. About 62% of the roots had some level of disease on them, right? So that's a lot. And looking at my RSA and RSD, these are comparable to your ESA and EST here in Southern Maine, 59 and close to 6,000 pounds. And here I have my Quadris at 10 fluid ounce rate, band and broadcast, and Quadris at 14.5 band and broadcast. Look at some of the numbers, right? 6,000 pounds versus 9,000 here. 9087, 9043, about slightly lower 88 and 86. Statistically different, it's a slightly lower for this one, but very good compared to the non-treated control. Again, this is the very first year. Cannot really explain, why this is the lower rate is slightly higher compared to the higher rate. Excalia, band 0.64, and then broadcast at fluid ounce, 9,200 and 9,400 pounds. There's no difference between these two methods for Excalia, pretty good compared to the non-treated control. Look at the 33% versus 0.1 or 1.3, very, very low disease development. And I got asteroid here, 9.2, and then Elatus, band and broadcast. So I'm going to share this presentation with Mark so they can post on their website, so you'll have time to look at these numbers. But again, what I'm trying to tell is the most fungicides that we tested, both as band and broadcast, work really well for managing Rhizoctonia here. Asteroid 98, 8,900, Elatus 8,500 and 8,900. So again, very less root rot development there. So when we compare band and broadcast, right? So now this is across all the fungicides that I showed. 9,100 compared to 8,990 broadcast, right? The band again slightly topped, slightly higher compared to this one, but statistically it's not any difference. So the message, at least based on 22, I think if you don't want to do the band application for Rhizoc, take your broadcast and then get it done. I think doing it better than not doing it at all. Won't have any band applicator. So we're going to repeat this trial in 2023 again. And this is some of the data from the previous trials. I think this is from 2020, right? So every time you have a specialty variety, you may or you may not see response from the post-emergence application, especially the 4 and 8 leaf application. But if you have a susceptible variety, you can get a good response for RSA. This is, I think, from 2020. And 2021, another trial that's done in your neck of the woods here. But here, see the resistant variety from 27 tons with a 4 or 8 leaf application, you got 32 tons. And if it's a susceptible variety, it's 27 to all the way to 37, right? That's pretty good bump for a susceptible variety. So I think sometimes it depends on do post-application and when you want to do your post-application. But I think the message to you is if you have a susceptible variety, it's better to do this post-emergence application earlier than later. Because a resistant variety have a little bit time because, by the time beets reach 60, if the natural resistance, then get it done about 8 leaf application, so you get that extended protection in the season. And here again, this is a good chart. Basically, I did this color coding, all the options for seed treatment, info, and then the post-emergence one here. What is SDHI? Some of these are QOI and DMI based on the mode of action. And this is the only one with 2 different modes here. But I think just like Spectroscopy, I think if you can rotate between fungicides with different modes of action, I think even for Rhizoc, that's really good practice because you're not exposing the fungus to the same class of chemistry. What happens eventually, you're going to lose the sensitivity to this particular fungicide. So with that, I think you can select strong varieties, especially that you have a ton of Rhizoc, you have a lot of susceptible crops in the rotation. But sometimes you may not expect any benefit, especially under the low disease conditions. The seed treatments work very well. They work probably up to 4 to 5 weeks after planting. And when you see some of my data, if nothing is happening at 6 or 7 weeks, it does not mean that seed treatments are working. I think it's the inactin that we put out, it's not potent throughout the season. And it's very good right away, and then it will start losing its power. For the in-furrow fungicides, they offer early to mid-season protection, but I think when the season is dry, especially if you use 1034, sometimes it can hurt stands. The fields with severe rhizoctonia, you can lose some stands, but we always have a big benefit by the end of the season using in-furrows. And post-emergence application, we used to say when soil at the 4-inch soil temperature hits 65, but I think my message is between 4 and 80, depending on when it works out for you. But again, the July and then some of the August weather is going to decide how much root rot you will have later in the season. And for susceptible varieties, generally I think a seed treatment, then the post-emergence is a good practice. That way you're overlapping some of the early season and then the mid-season. But if you have a field with severe history, I think it can benefit from the seed treatment, in-furrow, and also post-application. Aphanomyces, it does not need any introduction. I think you're using lots and lots of lime. If you have aphanomyces, again, aphanomyces does not kill the seed in the soil. They always emerge and then they get nipped just at the soil line. But as you go later into the season, if you have enough moisture, you will have a lot of root rot on a very simple Rhizoctonia here. So you got some pointers here from Todd, so I'm almost done. Another thing, I showed some, few samples early on with the Fusarium. The tricky thing with Fusarium, you don't see anything on the surface of the root. Everything is just inside. When you cut the roots open, you see these necrotic areas because they're actually colonizing the vascular bundles and then messing up with the water transport. But if you look at the leaves, you can get half-leaf necrosis. That's a classic sign. Sometimes it's just only at the tip of the leaf, or sometimes it's the entire leaf, right? And the main thing is to get diagnosed whether it's Fusarium or not, because that follow potatoes. Some of the symptoms look very similar, but that's caused by verticillium. It's not even Fusarium. So if you're falling potatoes, you still need to get diagnosed. With that, I would like to thank my crew for all the help and then hard work that they put in for this project. I would like to thank the co-ops for all their support, and also the growers, to let them use the field and to get research done. So we actually know what happens in your own field. Not the research plots are sometimes different than your field. So very thankful for that.